I'm just going to start this example over again because I got to different spots in different classes. So we're going to work with the cone here. Water's running into the tank, which is in the shape of a cone. So I like to go like that. I've got water going in. It's filling up. It's going in at a rate of 2 cubic feet. Let that units guide you. That's a change in volume. So I'm going to write that down, that the rate of change of my volume with respect to time. Since the water is going into the tank, the volume will be increasing, so I'll use a positive 2 for my rate of change. The tank is standing point down and has a height of 10. That gets to go on my picture because the height of the tank does not change. The height of the water does, but the height of the tank itself will remain constant through the problem, as will the base radius. So then I am looking for how fast is the water level rising. So I need a variable for this water level right here. I'm going to call that h. I also have a radius of the water as well. So I am looking for how fast the height of the water or the water level is rising at the instant when the height of the water is 6 feet deep. So that's kind of my snapshot in time. And I need a relationship now between volume and height. So my volume formula is, for a cone, volume is equal to 1/3 pi r squared h. I want to relate volume to height though in this problem. So what that means is it'll be to my benefit to replace the radius with an expression of height. So you can see with these are similar triangles here. So the height is twice the radius. But I would like the radius in terms of the height. So I'd say half the height is equal to the radius. And you can see it numerically there with that 10 and that 5 as well. So I'm going to replace r with the height cut in half. And then I'm down to an expression that links volume to height. So volume will be equal to 1/3 pi. The radius becomes h over 2 squared h. Notice I'm not doing anything yet. I'm trying to simplify this and get a really good expression. Excuse me, I have to cough. A really good expression for volume. I'm going to clean that expression up. Then I'll take the derivative. So I'm going to go clean up the right-hand side. H over 2 squared is h squared over 4. So I would have pi over 3 times h squared over 4 times h. Equivalently, that would be pi h cubed over 12. And that's an expression for my volume, all cleaned up in terms of the height. So now I'm going to start that water level rising up here. I'm going to start filling it up with water, and that would be my derivative process. Take the derivative of the left-hand side, set it equal to the derivative of the right-hand side, but in doing so, it's nice to pull the constant part of the product out front. Next, I'm going to use my chain rule over on the right-hand side. I'm going to have pi 12ths. The derivative of h cubed is 3h squared, but h is itself a function of time, so I need to multiply by the derivative of h. Right now is when I need to stop the clock or take my snapshot, but before doing that, I'm going to simplify. And whenever you can see simplify possibilities, do so. Simplify early and simplify often if you can. So right now I'm just going to take the opportunity to cancel those off. I don't have to do it now, but it's generally to your benefit to, why did I put a 14? To simplify early and simplify often. All right, so now I'm ready to find what I'm looking for at that snapshot in time. Remember, I'm looking for dh dt at the moment when h is, and you don't have to go reread the problem if you've already organized it. Your screenshot is going to be taken when h is 6. So we're going to stop the clock momentarily in time, and we're going to replace h with a 6. dh dt is my target. dv dt, go back on up, was given to me. It was increasing at a rate of 2, so that will become a 2. I get 2 is equal to 36 over 4 is 9, so I get 9 pi times dh dt. Solving that for my target gives me 2 over 9 pi, would be equal to the rate and change of the height. It's positive because the water level is increasing. If we were using our calculators, we would round that to 3 decimal places, but I don't have a calculator out. But keep in mind when you do that, make sure you do 2 divided by, make sure that 9 pi goes in parentheses, or do 2 divided by 9 and then times pi, and it'll give you this answer. That's a pretty common mistake. Now, I also haven't given a label to it, and a label is very important. This is the rate that the height is changing over time, so I need to put my units for height over my units for time. So you have to go back up to the problem and take a look at what your units were. This is in feet and the unit of time is minutes. So I am going to label this feet per minute. If I had to write a sentence explaining it in the context of the problem, I would say at the instant that the height is 6 feet, the change in height over time is increasing at a rate, or the water level is increasing at a rate of 2 over 9 pi feet per minute. Next up, we're going to change this to cylinder. I think we just did a cone, so let's shake it up a little bit. We're going to do one where you can't, remember in that last problem, I solved it for the radius in terms of the height, and I got it down to a single variable. Sometimes that's not possible because, let's go take a look. The radius of a cylinder, let's change it, is increasing at a rate of 2 centimeters per second while the height is decreasing. And you might say, well, how can that happen? Picture maybe like a cylindrical slug that's being heated, and maybe they're making little ball bearings. No, ball bearings are circular, but little cylindrical slugs. And they're heating them and they're squishing them down, which makes the height decrease and the radius increase. And while they're flattening that thing under the heat, the volume is also changing. And I'm looking for the rate that the volume's changing. So let's draw ourselves a cylinder because I changed the problem. Okay. And I am actually squishing it down and it's expanding. The radius is increasing. That does not go on my picture. That is not a constant. Okay, so my radius for this is changing. Now there's one on your problem set where it's a coffee pot being filled up, and I'm not changing the size of the coffee pot, so that constant can go on my picture, but that too cannot. I have to call that dr dt, and that's positive because it's increasing. The height is decreasing, so the height of this cylinder, I'm squishing it down, is decreasing, so we're going to use a -1 for that. Find the rate, there's my target. I'm looking for dv dt when r is equal to 5 and h is equal to 3. So I'm going to stop squishing that thing down the minute the radius reaches 5 and the height is 3, and find the rate that the volume is changing, which means I need a relationship between these 3 quantities. So I write volume is equal to pi r squared h. And I don't get it down to one variable because I'm looking for dv dt, and it's dependent upon both the r and the h, and I can't replace one with the other. I have no ratio to use like I did on the last one. So I just have to start by taking a derivative of the left, setting it equal to the derivative of the right while pulling the constant, the constant out of the way. The derivative on the right is going to need the product rule. So let's go do that. We do first d second plus second d first. The derivative of r squared is 2r, but with respect to time, I have to multiply by dr dt. I'm now going to replace all variables with their numerical value. R squared is 5. dh dt, I can't see, is -1. H is 5, 2 is 2, R is 3, and dr dt is 2. So when I clean that up, I've got a -25 plus 60, and that's going to give me 35. So I have a positive 35 pi, which means the volume's going up quite a bit as I flatten that out. Usually as you increase a radius, things grow more than when you increase a height, because in the volume formulas, the radius is squared, so it causes a greater increase overall. Anyhow, just a little tidbit. And this is change in volume over time, so I have to make sure I label that properly. I have to go back and look at what are my measurements. They are in centimeters and seconds. So volume would be centimeters cubed over unit of time, which is seconds. Next up. An airplane is flying at an altitude of 5 miles. That would be a constant. It's just flying along. So let's go have that airplane come zipping along here at an altitude of 5. It passes directly over a radar antenna. Let's say that's over here. There's a radar antenna. When the plane is 10 miles away from the antenna, the radar detects that the distance S is changing at a rate of 240 miles per hour. What is the speed of the plane? And the speed of the plane is going to represent this horizontal change. And I could have drawn my picture also like this. I could have put the antenna right here, but either way, I'm good. So let's go take a look at what we're finding. We need the speed of the plane, which would be represented by that horizontal rate of change. It's flying at an altitude of 5, that's a constant, and we are going to find the speed of the plane. So dx dt at the instant when s is 10, and it also, that's what I'm being asked to find. I'm going to put a little f by that, and it gave me something else. Oh, it gave me the radar detects that the distance s is changing at a rate of 240 miles per hour. So it also gave me ds dt. I usually like to have the given come first, but I don't want to rewrite this. So I need an expression that relates these. X squared plus 5 squared equals s squared. That does not simplify right now, so I'm going to launch in, take the derivative with respect to time of both sides. Using the chain rule on x squared, the derivative of a constant is 0. This becomes 2s, and again, chain rule again. I can simplify right now, so I might as well. My screenshot in time is going to be when s is 10. Okay, so I'm now going to replace that with its 10, and I'm going to go figure this out. Well, what is x when s is 10? I need that because I have to plug it in. So I have 5 squared plus x squared is equal to 10 squared, or 100. That'll give me x squared is equal to 75. X would be the square root of 75, which will be 5 root 3. All right, so I've got 5 root 3 times dx dt, don't know it, that's what I'm looking for, is equal to s at that time, which is 10, times ds dt, which is 240. So I'm going to divide both sides by 5, giving me a 10. I'm going to have dx dt equaling, what do we have there, 480 over square root 3. I like to clean up that denominator when it will cause cancellation, but technically you're allowed to leave that root in the denominator. Kind of bugs me though. I'd have 480 root 3 over 3. Right? So that would be 160 root 3, I believe. And that's the speed of the plane, and that would be in miles per hour. Or was it in kilometers? I don't remember. Miles per hour. All right. Last one. This is a classic AP. Actually, this was number 8 on an AP test. And it's a person who is 6 feet, and that's not changing. He's not shrinking when he walks away from the lamppost. And height of the lamppost is 15, also not changing. He's walking away from the base of a street lamp, so he's walking this way. At a rate, I got to call this x so that I can say dx dt is equal to 4. I think I'll go put that right here. dx dt is equal to 4. Again, it's positive because that length of x is growing. If the height of the street lamp is 15 feet, what is the rate at which the person's shadow is lengthening? Well, the shadow needs a variable. I'm going to call it y. And I am looking for dy dt, right? And it says if the height of, I'm good to go. All right, so I need to set up a ratio. And what I need to do is work with similar triangles. From geometry, I'm going to say the height of the lamppost is to the height of the little fella in exactly the same proportion as the base of the big triangle, which is this whole distance, x plus y, is to the base of this small triangle in here, which is just y. Now keep in mind, I'm in search of dy dt, so it'd be to my benefit to get a function of y. So 15y, using cross multiplying, will be 6x plus 6y. And honestly, I could have reduced that 15 over 6, but since I didn't choose to simplify early, I'm going to have to do it later. I'm fine with that. I'm going to subtract 6y from both sides. And again, I'm choosing to solve for y because I'm looking for dy dt. I'm going to get y is equal to 6/9, which is 2/3 x. I haven't done any calculus yet, so I've used some geometry to set up a proportion. I did some algebra cross multiplying. You did some combining of like terms. I've solved an equation for y so that now I can take its derivative with respect to time, pulling that constant out front. Remember, I'm in search of dy dt, dx dt at all the time, because you're walking at a constant rate, was 4. So I get 8/3. So let's go look. That was multiple choice, I believe. Let's go find 8/3. 8/3 would be 2 2/3, which is B. Now, before you quit the video here, your assignment, this will be due, this is 2.6a. It's going to be due on Wednesday, but you will get some more work on Tuesday that you're going to work on in class on Wednesday. So you might take care of this one on Monday and Tuesday night. And they're not very many. Almost all are odd, so CalcChat can help you out. They might have a little different notation and do things a little differently. So make sure you're not just copying it, but you're absorbing it. Sometimes, though, I was going to tell you, sometimes what they ask you for with this problem, and by they I mean College Board on the AP test, they'll ask you for the rate at which the tip of the shadow is moving. Well, just like this guy is x from the base of the lamp, and the rate that he's moving is called dx dt, the tip of the shadow is x plus y away from the base of the lamp, and the rate that it's changing would be the derivative of x plus y. And the easiest way to do that is just to do the derivative of a sum is the sum of its derivatives. And so really all I need to do is add up those two rates. The rate that he's moving plus the rate that his shadow's moving will be the rate that the tip of the shadow is moving, which would be dx dt was given to me as 4, and I just found dy dt to be 2.667 or 8/3, right? So the rate that the tip of the shadow is moving is 6.667. It's kind of interesting. Your tip of your shadow moves faster than you do. It also catches up to you faster when you go that way. Kind of cool. Anyway, so there's one in your homework, I think, like that, where there's a part A and a part B. And CalcChat does it differently. They call this whole length X, and then this shadow Y, and then this X minus Y, and it makes it more complicated. Do it the way I did it, and find dx and dy first. Even if it's a part B that says to find the length that the shadow is moving, do that before you find the rate at which the tip of the shadow is moving. Anyway, we are done. And that's your assignment. Due Wednesday. Give it a whirl, though. Give a couple of these a try, maybe. Don't put more than 15 minutes of time into it tonight, and then wrap it up on Tuesday night. Have a good one, guys.